Alright, so the next important idea I want to talk to you about in probability is the distinction between an independent and a dependent event. And these words basically mean exactly what they mean in everyday speech. Two events are independent when one of them does not affect, or the chances of one of them doesn't affect the probability of the other. So there's a great example in gambling. Okay, you might have heard of this before. It's called the gambler's fallacy. And I'll give you a simple example. Suppose you flip a coin 10 times, right? And it lands on heads 10 times in a row. The gambler's fallacy is if I were to ask you, what do you think is going to happen on the 11th time? Most people would say, well, I think I'm probably going to get tails. I just got heads in a row, heads 10 times in a row, so my luck is going to be running out. I'm going to get a tails. And that's a fallacy, because these events, every coin toss is an independent event. It has nothing to do with what happened on the prior coin toss. So that's what it means to say that two events are independent. Okay, I think it'll be clear when we do a couple examples. So here's kind of the notation for this in terms of stats. If two events are independent, if event A and event B are independent, then the probability of B given A is just the probability of B. In other words, the second event is not at all affected. So this is the opposite of that king and queen card example we did. You saw that it was originally 4 out of 52, but when we removed the king, that changed the probability. Okay, and the same is true the other way. If the probability of A given that B occurred is the exact same, probability of getting a heads on the 10th is the same as the probability of getting a heads given that it occurred on the 9th. It really doesn't matter. Okay, so let's do a couple of these problems, and then we will be able to, I think, understand slightly better. Okay, so first we'll just classify these to determine whether they're independent or dependent. Okay, picking a king from a deck of cards, not replacing it, that's really important, not replacing it, and then selecting a queen. Those events are going to be dependent, because dependent means that the first event influences or affects the outcome of the second. If I'm not replacing the card, then how many cards are left when you go in to pick this king? Or sorry, when you go in to pick this queen. When you go in to pick the queen, now there's only 51 cards left, so that is definitely going to be a dependent event. Okay, and you can see the numbers given right there. The fact that we pulled a card out and didn't replace it, that's going to affect the outcome. Alright, this one says tossing a coin and getting a head, then rolling a six-sided die. Those are going to be, think about whether they would be independent of each other or dependent, and hopefully you were able to tell that those are independent. Okay, flipping a coin has nothing to do with rolling a die, so those things are not going to affect each other. Driving over 85 miles an hour, getting in a car accident. Well, hopefully people listening to this video are safe drivers and would understand it's very rare that the speed limit would be that high. So these events are certainly influencing each other. Driving over 85 is going to increase your likelihood of getting in an accident, so those events would be considered dependent. Okay, so that's the first thing to understand, is just the distinction between those two, dependent versus independent. Again, independent means the events do not affect each other's probabilities. Dependent means they do. Okay, so we will do a couple more examples with this in the next video.